Bismillahirrahmanirrahim. Okay guys, welcome back to our subject for electronic 1. So as of today, we shall continue with our subject or chapter regarding AC-DC converters, half-wave rectifiers. Okay, to recap the previous lecture that we have went through. So actually the power electronic or this subject we shall learn overall or in general is about how to convert the incoming waveform, sine wave, AC, DC, whatever pattern of incoming, into the required load requirement waveform. Maybe at certain level DC, different level of DC, at certain level of frequency of AC. So this is where our converter or power electronics concerned. How to convert the signal from input into output requirement. Okay, then we shall go further into what are the contents or the device that contain inside this converter. Okay, so the main things about power electronics is about the conversion system. Okay, as of for this chapter, we shall go through the outcomes of the subject or the chapter, and we shall went through or see the type of rectifier that contains inside the converter. So the rectifier will consist of either or will be processed using rectifier here. Will be processed either in kind of uncontrolled, controlled, or uncontrolled but with the RL load. So first we shall use only resistive load as our reference. This one also resistive load but with the controlled and rectifier. Then we go to the uncontrolled but using another more to the practical load of resistive plus inductive components. Okay, throughout this chapter, the learning outcomes, we or you should able to develop. We should induce you all, but you yourself should able to develop in terms of your understanding on the topology and how the rectifier topology looks like. And simple half-wave rectifier, we have source, we have DC, we have diodes, then we supply to the resistive load. So this is the topology, the schematic topology of the system, and how it operates. So if you have a source, time domain shape or pattern, we have a sine wave up and down. So when we go through the circuit, let's say that for the half positive conduction, so the current will flow to the resistive load, come back to the source. So we know the operation, how it operates. Then when the negative cycle, empty cycle happen, so the current will flow backward. But it stops here. Means that at the output, you shall see only the positive part flows, negative part it blocks, then it appears again on the next cycle of the positive flows, conduction, positive conduction. So this is the operation of the system. And then we should know in terms of characteristic of the rectifiers. So different rectifier, it should behave in different kind of characteristic. Maybe at what kind of level it will switch on, what kind of voltage, what kind of current. So how each of the rectifier behave depend on the characteristic and depend on the load, depend on the source, and how the behavior of the rectifier itself. Then you should be able to develop yourself and in terms of the ability to analyze the rectifier topologies. So you know the topology operation, so you know to analyze, and you should able to see what happened to the output. So you should able to anticipate what actually happening in the circuit, and able to develop the ability to theoretically quantify and evaluate the performance of rectifier. Later we shall go through to see in terms of how much we put in as input, how much it goes as output, and how much actually it goes or it turns into loss. And so the performance. When we talk about performance, means that the efficiency. P out is high, P loss is low, so the efficiency is high. And so you have a high efficiency. And you should be able to develop in terms of, or able to develop and design rectifier circuit by applying the theoretical concept. Means that later, if you want the output to be not only like this, but maybe rather like half wave, but maybe a little more half than a half wave. Let's say we want to have a lower amplitude average. By right, we should have a full half wave like this. Okay, but we need a little lower bit or a lower output average. So the output should be, let's say, like this. So we have a quarter output like this. So how actually you want to assign your circuit here to operate? So for this is uncontrolled rectifier. Let's say you use a semi-controlled rectifier or a fully controlled device. So how you should put as your triggering signal to the rectifier itself, and how it should be triggered. What are the starting point? What are the ending point of the signal? And how you want to develop this kind of signal. Okay, is that a rectifier circuit? Applying theoretical concept. So theoretically, you want to have this kind of signal at the output. So, and theoretically, this kind of signal should be applied. So how you want to develop or design this kind of circuit and rectifier circuit to accomplish the aim. Okay, that's the learning outcomes. So again, what are the converter we are talking about now? So for this chapter, we shall go through only on the AC to DC converter. So later we shall have a DC to DC, and then DC to AC. Like I told you, if you talk about AC to DC converter, so usually the other names for this kind of converter is called a rectifier. And AC to DC converter, we convert from AC alternating waveform into a static output average output like this voltage. It's so called a rectifier. We shall rectify the alternating waveform into a standard or average output, DC output. So this is called so-called rectifier or AC to DC converter. Convert AC input into DC output signal. So we have a few types of this kind of rectifiers in the market, which is if it is applied to the single phase system, it's so called a single phase rectifier. But when we are dealing with a three phase, so we will call a three phase rectifier. Single phase means that we have one source of AC rectified into load, and so this is single phase. If we have three source, red, yellow, blue, so we shall have a three phase rectifier. Three phase rectify into single output and single DC. If you rectify each of the output into single DC, so it's still a single phase rectifier, but three input of AC combined together into one output, so this is so called a three phase rectifier. Okay, we have a half wave or full wave rectifier. Full wave means that we are rectifying all the AC and positive and negative pole into a single DC output. Before it reaches single DC output, we shall have a pattern of only positive part is rectified. Okay, positive part rectified. Negative part, it just block here. Doesn't project the output. What about full wave rectifier? So the full swing will be rectified. The positive also rectified. The negative part also rectified. So we shall have a positive. Then the negative also invert here, become a positive average output. Okay. Positive part rectified, negative part rectified, positive part rectified. All the phases, poles is rectified. So this is so-called a full wave rectifier. What about control and uncontrolled rectifiers? So if we use only the device which is diode. So this is uncontrolled rectifier. You have a positive bias, so the current will be flow into. You have negative flows, so the current will be blocked. But for the control rectifier doesn't mean that we use only diode. Maybe we use SCR. Maybe we use MOSFET. We use MOSFET. So use MOSFET. Maybe we use transistor. So the rectifier is a system, not a, it's referring to the device, a system to rectify. So control or uncontrolled rectifier. Uncontrolled, we use diode. If you control the rectifier, means that we are able to control. We induce the gate control system, control device, gate control mechanism. So we able to control on and off. So it's so-called control rectifier. We are able to control when to switch on or when to switch off. Instead of output, we might have some sort like maybe a full wave like this, maybe a partial wave like this, maybe a partial wave of full wave like this. So this is so-called a control rectifier with a controllable device. Okay. Then, okay, we have here single phase, the table or the tree of the families. Type of rectifier, we have single phase. With that single phase, one output, one input, delivering the output into the one or single load. Okay, single load. One output into one load, and one input into single load. So what happened here? The difference only that this is a full wave rectifier composition or layout topology. Meanwhile, this is for half wave. See, the half wave only, if you want to rectify half of the wave, you only requires only single device. Okay, means that it's rectified into a half wave. Okay. Meanwhile, if you require both poles to be rectified, so you need a full wave rectifier. Is that during positive cycle, it flows here into the load, back to the source. During negative cycle, it flows here. See, positive poles, a positive cycle also at the load point of view, and return back to the source. So both are rectified. You shall see output like this. Okay, at the load. When you take a look or you probe at the point, load point, the input is AC lah. Okay. Meanwhile, for AC, for half wave, only half positive is rectified. Positive cycle rectified, negative cycle it blocked. So block, so you have a zero reading at the output. Okay, for half wave and for full wave as well, we have uncontrolled and controlled scheme. So if you just want an uncontrolled method, so you just put diode. And if you want a control, you can put thyristor. Else you can put later MOSFET IGBT as well. But for this time being, we just talk about thyristor. Okay, then you have a gate here. You can see the gate, the gating point. Okay, so this is your gating point here. You shall induce a current to switch on, and it will off for during a negative bias. So same goes to the full wave. So you just replace this point, this part, with a diode for uncontrolled, and for a control, you can replace with a thyristor. Okay. Okay, we continue with the next slide.